Okay, we are live again for the third stream of the day. Now we're doing structured programming, returning from the midterm exam. We have just graded homework 4, but since a lot of people didn't do the homework at all, I want to go over the example I made. I made it 27 days ago for you guys to go over so you wouldn't struggle with the homework, but a lot of people decided not to look at it anyway. So basically, we were making a calculator in reverse Polish notation, and we wanted to have variables. We wanted to be able to say that A is 3 and B is 7 and C is 6, etc. So I have an array to put the variables. I'm only managing 3 variables in my example. That's why count is 3, because just it's going to be A, B, C. If you would like 6, then it would be until F. I have variables to put current values. I have very many auxiliary variables. It's a bad idea to name a variable read. It could just be an R or something. I have some flags for whether things have been defined. And I set all the variables as undefined in the beginning. Then I'm simply going to use the get char to read characters one by one. Whenever I get an enter, it means that we're actually going to start processing whatever the person typed into the calculator. So when we see the enter, we are going to calculate the value. And if we got something that isn't an enter, then we're actually going to be storing more information. So when I get digits, I'm only managing single digit values here because I wanted to leave it to your exercise to make larger ones. So my calculator can work with numbers from 0 to 9 because I simply take the character, I subtract the 0, so then I get the decimal value between 0 and 9, and that's going to be the digits that I am processing. Then I need to figure out what value am I expecting. If I already have a left operand, I'm expecting a right operand. If I already have 2 values stored, then I'm expecting an operator, like the math operation we are going to do. If I needed still a left-hand side value, the new digit I was given goes to the left side. If I didn't need the left side one, but I needed a right side, it goes to the right side. If I already had a left and a right value and I was just waiting for an operator, then I'm going to complain. I'm going to skip it because this is not something that we can process. I've been given too many operands. If I get a letter, then it means that we're actually looking at a variable. And which variable? I'm again going to use the ASCII code. I'm just going to subtract the ASCII for uppercase A. Notice that I convert all the letters to uppercase, so the variables are going to be uppercase, regardless of how you type them. It's going to complain if I'm trying to access a variable that's a letter that's too high on. If the variable actually exists, it's an ABC, then I need to figure out what's going to be happening with it. Is the user trying to give a new value to the variable, or is the person trying to access the value? That depends on what's happened before this letter, whether or not there has been something indicating I would be assigning to the value. If I try to access a variable that doesn't exist, I get an error. Then I do the same stuff I did before, the deciding whether it's going to go to the left or the right, just like the number that I read, which is why I'm saying that this would make sense to put in the subroutine, because the processing of where does this value go, it really doesn't depend on whether it comes from a variable or whether it comes from the keyboard. We still need to figure out whether it's left or right or left over. Then if I'm expecting to see an operator, it could be the assignment. So I can just say assign A2 to mean that A is going to have the value 2. If I don't have both left and right side defined and I get an operator, I need to complain because I can't calculate. I need to have both of the values. If I'm looking at a plus sign, well, then I'm getting a sum. If I'm looking at a minus sign, I'm getting a minus. If I'm looking at an asterisk, it's a multiplication. And I only included those 3 because I was hoping you guys could expand it in your homework. If I got a new value, then I am going to store the new value as the new left operand, and the right operand is going to be blank. I'm going to wait to get a value for it. And that's my code. So let's go run my code briefly. So it doesn't do everything that I was asking for you guys to do in the homework, but it kind of like gives a pretty good head start. So let's go there. Let's get the new version of the code. It's under chapter 4. I can't type. So let's compile it. When tab completion starts working. And let's run this. So I said I could assign variables. I could say stuff like A is going to be 4. B is going to be 3. So then I could say stuff like A, B plus to sum the value in A to the value in B. Or I could say like 5A, I'm going to sum those, and then I'm going to bring in a 3, and I'm going to multiply. Then I'm going to bring in the value of B, and then I'm going to subtract. So first, I'm going to take the 5 and the A. I'm going to sum them. Then that result is going to be multiplied by 3. And from that result, I'm subtracting the value of B. So this is what my example code does, which I provided to you guys about a month ago. And you can just exit the whole thing with a Control-C. I'm going to link to you guys on Discord the code, and I'm going to put the screenshot of what I just did so you can see how I meant to use it. I'm clicking on the wrong things here. Thursdays are hard for the soul. So that's where the code is. Now, let me explain the new system we have. When you're looking at the stream, you can see that there are like little faded buttons on the side, like a green one and a red one and a yellow one and all that. So that's a new system I made, so I will know whether you guys are okay. So if you guys are my students and you're on Discord, you could just use the Discord to modify those. If you're not on my Discord, just go to my webpage. There's a link for interacting, and you can put your email and start clicking on the buttons. So if you would want to show me green, meaning that you understand what's going on and you have no problem, you could type on Discord on the channel of the class, simply !vote green. And that's going to give us a green vote. If you don't want to write it on the channel, you could just send it to the bot too. You can go to a private message, and there you don't need an exclamation anymore. You could just like vote yellow. You can vote in Spanish too. Voto amarillo, it works just as fine. Voto rojo works fine. Voto borrar would mean that you don't want your vote to be displayed anymore. So that's something we can totally do. So anytime you're fine with what I'm explaining, please use the green one. If you think I'm going a little too fast and you're starting to get confused, use the yellow one. If you need me to stop explaining because you have a question about something we've already talked about, use the red one. As soon as I see that there is a red one, I'm going to check both the chats on Discord and the chat on Twitch to see what exactly is going on so that I can stop explaining and start responding to whatever questions you had. If you have to step away because your brother is bothering you, or you're hungry, or the bathroom calls, or your cats are fighting, use the gray one. So I know that you're AFK. I know you can't respond to me, so I won't stop and wait for you. I'm just going to suppose you're going to watch the video later. And if there is a technical problem, if I'm showing the whiteboard, but I should be showing the computer, or vice versa, or you can't hear me anymore, or the stream is lagging, if something is wrong that I will need to check, then you vote for the black one, just to let me know to stop entirely and go diagnose my tech, because there's definitely something wrong. So I think this is easier than me asking you guys whether you've understood. Just remember, as soon as you start getting confused, you go yellow. As soon as you have a question, you go red. Stay green when you're fine. go gray when you have to leave, and you can get your vote off entirely by voting the blue or the erasing thing. If you simply need to leave entirely, you won't be coming back anymore, and you will just watch the video later, so I don't have to look at your vote anymore. So let's everybody vote green if we have understood this interaction system. And then we're going to start worrying about chapter 5. Okay, so I think you've changed your nickname in Discord, so it doesn't know your student ID anymore. Anytime you change your Discord username, it forgets what your number was. So anytime you make any modifications to your Discord username, remember to send your student number again to the bot, so it still knows who you are, because it's just trying to remember that this Discord user has this number. Okay, 4 people are fine. So what we're going to be doing today is pointers and arrays, and it's pretty important to be staring at a specific part of your reference card, because you're going to be perpetually forgetting when are you supposed to put an asterisk, when are you supposed to put an ampersand, what's going on, when it is an arrow, when it is a dot. So keep this part on your face at all times. When you don't know what a symbol means, or you can't remember which symbol to use, simply look at this part of the reference card. Everything's much easier when you simply check anytime you're confused. Okay. So what we're going to be learning about pointers is how can I access a variable that's being defined somewhere else? Because remember, thus far, if we make a subroutine, a function, the function doesn't see the values of the part that's calling that function. Let's do this in code. Why am I always just zooming in? I could just make the class terminal. New window. There we go. So let's try this out. I'm going to go again to the repository. Let's go to chapter 5, and we're going to make a little live demo for this semester. So I'm just going to call it AD21 part 1. So first, what we're going to do is we're going to make sure that we can actually print so we can see what's going on. Then I'm going to make a tiny little routine. It's going to be called sum. It's going to take an integer a, and it's going to take an integer b, and it's going to return the value a plus b. We're going to make a little main. It's going to return a, well, I don't know, it can return a 13 today. We're going to have some variables here. We're going to have an x, it's going to be a 4. We're going to have a y, it's going to be a 3. So we have here the x and we have here the y, and then we're going to want the sum of the x and the y for the last one. Let's compile this. I'll compile in the different windows so that we don't lose sight of the code when we're compiling. Maybe the code should be a little smaller. There we go. So let's compile this. And look at what it does. So it does this. We already know it does this. And this is all nice and wonderful. But now let's say I would want to make a routine that takes a number and it makes that number twice as big. So if I give it an a, what it's going to do is a is going to be multiplied by 2. Okay? This seems entirely and wonderfully valid. And we could actually type it here as well. And let's try here calling double x. So what I'm trying to do is I'm trying to make x grow to 8. I'm calling this double thing, I'm giving it the 4. It's going to be valued 4, and then it's going to be valued 8. And I totally break everything. Expected identifier, or oh, it doesn't like double because it's a reserved word. We're gonna have to call it make double. Okay, now it's a little happier, except I keep forgetting the F's in the prints. And let's run it. Okay, so first it's 4, then it's 8. Then it's 4 again. My dreams are ruined. I wanted it to be an 8. Why is it refusing to be an 8? This is the exact problem why we need pointers. The value of A that make double has, it's a copy. It's a separate variable. It's not the same X as in main. So this is not working. This is not doing what we want it to do. I want make double to be able to change the value of my variable. So what I'm actually going to do is I'm going to tell make double where I have stored that value. And I'm going to make double receive as an argument a pointer to A. So actually, here, if I want to see what's the value of A, I need to check what's residing in A. And here, if I want to change the value in A, I would also need to tell it that I want the value stored in A to be, let's write it a little bit easier. We could actually make a local copy here. So the value of A is that, and then I want the value of A to be twice the value of the copy. And now I'm doing exactly the part. This needs to be the pointer. The part of where I should be looking at the reference card. No, this is the value of A. This is the value of A. This is where A resides. That is where A resides. Expression is not assignable. The value in A needs to be twice the value of copy. Okay, so this is exactly why I say to look at the reference card. The ampersand is, give me the address. It's the where is X. Confess to me where is X, so that I will tell make double where A is. And this one is what is the value stored at the address. So I need to use the asterisk when I want to look at the value stored in the access or modify the value stored in the address. Okay, so now if I run it, first it's 4, then it's 8, and also in the main, it actually changed to 8 because I am not working with a local copy of it anymore. I am putting a new value to where it was. Now, of course, I could get rid of the copy part here, but it's going to look a little bit more confusing because the value stored in A is going to be twice the value stored in A. Compiling, running, still works fine. And now we could go back to the abbreviated notation. The value stored in A is twice the value presently stored in A. So this is basically everything you need to know to start working with pointers. Instead of copying the value when I go into a different part of the code, I am telling the different part of the code where is this information stored, and then that different part of the code can modify that information as much as it wants to. So basically, the authors of the book that we are reading visualize it pretty well here. Saves me the effort of drawing it on the whiteboard. A pointer is a variable that contains the direction, the address of another piece of information in the memory. So I could put the address of X even into a variable. So I could say that the address is a pointer and it's going to be the pointer to X. Then I just pass the address to make double. I have to compile, and it's going to make double. If I pass it the address of Y instead, it's not going to make double the 4, it's going to make double the 6. There. So now this is a variable, that's a pointer that can store addresses to other variables. The ampersand extracts the address, and then the asterisk follows the address to go to that location. So it means that when I'm using the ampersand, I'm kind of looking in reverse. Where is this information stored? Like I'm checking what's the address, what has to go in here. And when I have the address tells me where in the memory am I looking for this information. So this is what explained here in the beginning of the chapter. I could also do unitary operations with this. So basically, if I'm doing an asterisk IP plus equal 1, what it's going to do is going to go to where IP points at, and then it's going to add a 1. And if I want to do the plus plus afterwards, if I don't put the parentheses, what's actually going to happen is that I'm going to first increment the address, which means I'm going to move to another part of the memory, and then I am going to access the value. So you have to remember that the preference, the precedence in which the operators are evaluated affects where you need to put parentheses. Whenever you have any doubts about what's going to be evaluated first, you simply put the parentheses first. The precedence is explained here, that structure members, the points and the arrows we're going to see in a little while, those have a very high very high preference. Then what we get are the increments, decrements. Then we're gonna get logical stuff. We're gonna get regular arithmetic. We're gonna get bit shift. We're gonna get comparisons. But you don't have to memorize the precedence as long as you always put parentheses when you're not certain what's going to happen first. And whenever something weird happens, just add parentheses to make sure that what you are expecting to happen actually happened. The section 5.2 explains what we just did with our file by implementing a method that's trying to exchange the values of X and Y. If I simply try to take a temporary variable, put X into the temporary and then Y into X and then Y into temp, this is going to utterly fail because I'm only modifying the copies. I'm not modifying the actual variables. So that's also easy to switch around by using the pointers, so that when a main routine or some other place has variables A or B, we tell the swap where is A and where is B, so that swapping can actually access their values. So I'm still kind of living in the fantasy world where you guys actually read this book. I'm not entirely certain if that's going on. So it's kind of important that you confess if you're unable to understand the book. Even if you read it after class, if there's any part in here that confuses you horribly, just take a screenshot of the confusing part and let me know. Okay, so section 5.3 explains to us what do pointers have to do with arrays. We've already been working with arrays where we say that I have 10 integers in array. What I actually have is I have a pointer to the beginning. And then I can access the locations by kind of like moving, incrementing the pointer by position to move further on in the array. So when you have an array, you actually have a pointer. And if you add integers to the pointer, you are moving forward in your array. So you could do this. This is called pointer arithmetic, instead of using the bracket notation to access the contents of an array. This is sometimes very, very practical, but it can also make things a little bit confusing. So what the authors are using to demonstrate this functionality in this section is they are rewriting a routine for checking how many characters does a string contain. So when you give it a pointer to a string, what we're simply doing is that we are incrementing the pointer until the pointer points to the end of the string. So we don't have to access the S with like S brackets N, but we can simply increment the pointer. And since this is a for routine, I could technically just put the N++ here as well. But I kind of want it to be the N++ happens first, then the S++, and then the comparison again. 5.4 explains other kinds of arithmetic you can do with the addresses. We're already talking about how we increment. We can actually move forward in an array. And this section explains how we are working with reserving a certain amount of memory. So let's say that I don't know beforehand how big my array is going to be. So I can't like type the number of how many places I want it to have. I could use routines to allocate and to liberate, and they're discussing here how that would be done. We're later on in the course going to use a lot of routine called malloc, which is going to allocate memory in exactly this way. Also, as you can guess, strings are essentially character arrays. So when I have a string, what I have is essentially a pointer to a character array. And this is discussed in section 5.5. So for example, if I would like to be copying one string to another, if I want to do it the old-fashioned way using the bracket expressions, I would do this. Whereas if I want to use the pointers, it's a little shorter because I can simply say that while I haven't reached the end of the strings, I am simply going to be incrementing the pointers. And at each comparison, I make S take the value of T. So it means that whatever was in T will also be in S when we're done. So basically, by operating with pointers instead of this notation, you can make it look a little bit shorter and possibly run a little bit faster. But I wouldn't really worry about this as a starting programmer. This is just as good as this. It's good to understand this, but it doesn't make you dumb if you only come up with this. It takes a bit of practice to start recognizing in which situations it's actually more convenient to work with the pointers directly. So our learning goals here are a little easier. The exercises are really good. If you want to dominate well the use of pointers and how do they work with strings and arrays, all the exercises in this chapter are really recommendable. Okay, now we get to the fun part. Let me push to the repository what we just did. So now I could make pointers to pointers. Why would I want to make pointers to pointers? If I would want to have an array that contains strings, each string is essentially an array. So I'm actually going to make a pointer that points to a string pointer. So this means I can also make two-dimensional arrays. I could make a matrix. So let's make a matrix. So we're going to need a situation where I actually have an array that contains arrays. So we can do that by making pointers to pointers as described here in this chapter. And this next section is about the same thing, because essentially when I am using a pointer to a pointer, I'm working with a multi-dimensional array. You could, of course, define them manually, but that's kind of silly. Everybody's just going to be working with pointers to pointers in the real world. There's information on some little tiny differences of notation. And also, actually, finally, there's an explanation. We're going to look at that after we look at the matrix on how to access command line arguments, because that's also a pointer to a pointer. So it's going to finally let us work a little bit better. So let's make a matrix, just a tiny little matrix. I'm going to start using that malloc thing that I mentioned to reserve memory. Trying to comment as if we're Python. So let's make a 3x3 matrix, because those are really popular at our faculty, because you can do kind of the interesting, what's it called, metodo montante, that everybody's really impressed with at our school and nobody knows anywhere else. So we're going to make a 3x3 matrix. So my matrix, I'm just going to put integers in it. So every single cell of the 3x3 matrix is going to be an integer. The rows of the matrix are going to be arrays of integers. So then the matrix is going to be an array of rows of integers. So that's going to be my M. And first it points to nothing. I don't reserve any memory to it yet. I am going to want to be able to store the rows there. So essentially, what I need to do is I need to reserve memory. How much memory do I want to reserve? I want to reserve dim rows. And then we have to think about how big each row is. And we're going to need to tell it essentially with size of what's the stuff we want to put there. So I want to be able to put there integer pointers, because each row is going to be an array of integers. So I need 3 integer pointers to make a matrix. Then I will need to make the rows. Let's make an auxiliary thing here for the rows as well. And let's make int just to move forward. So while I is 0 and I is smaller than the dimension, I need to reserve every single row. So mi is going to be the ith row of the matrix. And that thing is going to be a dimension times size of an integer. We're going to get a couple of compiler complaints later on. I'm going to just write it as simple as possible first. Then when we don't want the matrix anymore, we're going to do stuff with it here. When we're done with it, we're going to have to liberate it in the opposite order. Liberating it is kind of like when you don't need something anymore, you need to throw it away. When you've gone to the bathroom, you really need to flush, and it's the same thing here. So if I reserved it, the rows, I need to liberate every single row. And then after I have liberated every single row, I can liberate the thing that the rows were stored in. So that's the pending stuff we're going to put. And now we're just going to look at the compiler warnings that we're going to get, because I am still missing stuff in the code. Oh, it doesn't complain. Well, we'll add them anyway. It's nice to say here that what malloc is giving me, it's going to be a pointer to a pointer of integers. And here it's going to be a pointer to integers. So I can run this thing too. It doesn't really do much. It reserves the memory and then it frees the memory. Okay, let's put values into the matrix and then let's print the matrix. So we could make it 1, 2, 3, first row, then 4, 5, 6, then 7, 8, 9. So I'm going to want another value here to be able to do a nice little double 4. So I is going to go from 0 to, so bad at typing that I should just copy this. And then J is going to do the same exact thing. Then I need some K that's going to remember what's the number that we're looking at. Actually, we can do arithmetic. In matrix position AJ, what do I want to put there? I want to put there dim times I plus J, so that it's plus 1, so that it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's figure out how I can see what's actually stored there. I'm going to make a routine that lets me print out this matrix. It's also going to need the double 4 IJ. For each row, first we want to print out the values that are in that row. We could print them separated by maybe tabulators. We can just separate them by spaces, really. I'm just going to put a space first. So we're going to print I, J. And then after each row, I need to print the enter to make it look pretty. And we don't really have to return any value from here. I forgot to say the type here. This is what happens when you program in Python. You entirely forget you're supposed to mention. So I now made this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Usually when people work with pointers, the biggest problem they have is they forget to reserve the memory, or they index the memory where they don't actually have it. So let's say that I don't initialize the last row at all. I just reserve space for the 1, 2, 3, 4, 5, 6, but I don't reserve space for the 7, 8, 9. Let's see what happens. Segmentation fault. What does segmentation fault mean? It means you are trying to read or write memory that isn't yours. So it was fine until I tried to put the 7 in there, because 7 wasn't actually defined. In a similar way, let's compile it again to make it work again. If I wanted to modify a position that actually doesn't exist, like 4, 2, if I want to put a 4 in there, it is going to cry because I do not have a row 4. I have rows 0, 1, 2, and I have columns 0, 1, 2. But if I want to change that 5 into a different number, let's say I want to put a 0 where that 5 is, then that would be row 1, column 1. I want there to be a 0. I compile, I execute, and now there's a 0. So what I'm dealing with here is essentially a double array, but remember, that's actually just pointers to pointers. So here, instead of doing this my, one is something, I could technically, it's just going to make it harder for you guys to follow if I start doing pointer arithmetic here. But here, I guess I could just put an m plus I first, and then I would sum a j to that. Let's see if this still works. expression is not assignable. Oh, because this is the pointer, and I am trying to assign something to the value of this pointer. And of this pointer. Okay, so now it works just fine, but I'm actually going to write to you the both versions here because it's usually easier to read when you're using the bracketed notation, even if you can do fancy stuff with a non-bracketed notation. And the same way here, if I want to access this one, I could also write it. Here I'm going to comment the pretty version away. So I could say that I want to go to the first row, take that value, and then I want to go in that first row, well, actually the second row because the 0th row is the first one. I want to go in the second row to the second value, and I want to take his value, and then I want to put 0 in there. So those are different ways of writing the exactly same thing. And here, instead of writing this, I could perfectly well write this, or as we already know, I could simply first liberate this, and then after I've liberated it, I could increment it. So this should work too, shouldn't it? So I would first liberate the, no, what's the precedent now? What's the precedent? Am I doing something dumb here? Who's going to happen first? Indirection of pointer comes after the increment. Now this is a stupid idea. This is a stupid idea because it's going to be really confusing on what's going to happen first. I think this is going to be fine enough. And now I broke it. Oh, because I took the I++ away. I can just put the I++ here, it's fine. Let's push this into, and then look at the command line parameters that I promised you guys. Okay, everybody is in green still. So when I'm running a program, I can make that program receive command line parameters. Like when I write something on the same line where I run my program, I can access the information given to the program. So we're going to have a special array called argv, which is going to contain the values of the arguments. That's why it's v. And we're going to know how long it is by another special parameter to the main that's called argc, which is the count of how many arguments there are. The name of the program is always going to be in the first cell, and then all the others are going to be parameters to our program. So to check this, we're going to make a copy of my AD21. Now it's going to be _2. So let's say I don't want to type the X and Y here. I want to give them when I run the program so that I don't have to recompile anytime I want to change the values of X and Y. So what could I do? First, I need to take into account that these values actually always exist. Regardless of whether I use them, they are always going to be there. And now I actually want to access them. So I would want X to be turning a string into an integer for the thing that is in position 1. Remember, position 0 is going to be the name of the executable. And in position 2, we could take the value of Y. So I compile this. I forgot to mention the std. No, it's C-type. Isn't it C-type? Let's ask the reference card. Reference card knows everything. A to I is in where? Thursdays are so bad. I'm bad at typing. I'm bad at reading. Here it is. It's an stdlib. So now, if I tell it that I want a 5 and a 9, it's going to use the 5 and a 9. And remember, it's going to make double of the second one. We could take the double stuff away now, so it's a little less confusing, so that the program doesn't do as many things. Since we're concentrating on the argc, argv stuff right now. Compiling, executing. So this is pretty nice because I don't have to recompile the program and I can make it do different things, right? Now, the bad thing about this, that let's say I don't know I'm supposed to give it 2 numbers. What do I get? I get a segmentation fault. Why did I get a segmentation fault? Because I'm trying to go to an argv that doesn't exist. So if I wanted to make this program idiot-proof, I would first have to check how many values do I actually have available, and then take their values later. So let's add the check. If argc is less than 3, then we need to complain to the user. So that the user knows that we need 2 integers. And we could return from here with a different code. And then if we actually have the parameters present, then we are going to read them and interpret them as integers. So let's compile. I run it, it complains. I run it with 1 thing, it complains. I run it with 2 things, it's fine. If I put a string, strings are taken as zeros. And if I try to put decimal values, those are taken truncated at the 1. So if I wanted this to work with floating point numbers, I would really just need to put the A to F. Talk about numbers here. My neighbor is smoking pot again. Oh, it smells like weed here. So now it asks for 2 numbers. And now I am reading floating point, but I am storing in integers, so it's rounding them. And I also need to remember to print them as floating points if I actually want them to be floating points. And if I want the sum to also be a floating point, I need to change the types here, because otherwise it's just going to force them into integers and we're still not going to see the decimals. Compiling, running. Now the bad thing is that it's showing me the decimals it wants, not the decimals I want. So let's force it to only give me 2 decimals. Nice. Okay, so let me push this one in as well. So this is very nice now. We can make programs that you don't have to recompile to change their behavior, because they can actually read data from the command line. And later on in the course, we're going to improve the situation even more, because we're going to start reading from files. When you read from a file, your user doesn't have to be typing all the info, and you don't have to be putting it on the command line. So this is getting more and more powerful. So let's add this file. I forgot to add it. Okay. Then there is a final thing that we can do, and we actually need to look into this a tiny bit, because I am going to ask this in the exam. We can make pointers to functions. What we're going to do here is we're going to modify the second code in a copy of it so that it doesn't get too complex. And we're going to make a pointer to a function. My neighbor's weed is killing me. So let's make it AD21.3. That one's going to have pointers to functions. So let's suppose that I want to do a different routine depending on what symbol the person types as an operator. So let's make an operator here. And that's simply going to be from the second command. We're going to take the first symbol. This one's going to be the third one. We're going to need a something like X operator Y is what we're going to need. And now I would want to use a different function based on which one I get here. And I would like to store the function in a pointer. So basically, I just want to run some f. And here I am going to want to print the character C. So I want to put a pointer to a function in terms of which operator did the person ask me to do. Let's change the names a little. Let's call this plus and minus and times. This one's going to be like this. This one's going to be like this. Nothing very complicated here. And now we're going to start making pointers to functions. So basically, I need to be able to say what kind of a pointer to a function am I going to have. Let's go a little lower here. Like for example, here I'm saying I'm going to have a function that's going to be a swap that's going to take these kinds of methods. So what are we going to have here? We're going to have a function that is going to be our operation, and it's going to take two floats. So that's going to be the function, and then I'm just going to be able to run that function. So here we're saying that we're going to have a pointer to a function. Okay, so I am going to have a pointer to a function that's going to take a float and a float. Okay, where do we assign a value to that? Actually, I think we're not going to need to look at the rest of this. That's correct. Okay, this is our pointer to a routine. Correct. Okay, I'm just reminding myself of the notation. It's also in the reference card. It's actually really practical to have all your stuff in a repository because whenever you forget how something's done, you just look at your own code. So now I need to figure out how to make this f point to the correct function. So I could make a switch case. I could make a switch using the O. And if O was a plus sign, come on, then f would be the address of the function plus. If I had a minus sign, then f would be the function minus. If the operator is an asterisk, or if the operator is an X, I'm going to accept both. just a little confusing if we say X here. So let's say those are number 1 and 2. In the both of those cases, F is going to be times. And if it's none of those, we're going to refuse to operate. And we're going to quit the program with a different code. Anytime we quit for any reason, we can just use a different return code. It would make it easier for the operating system to understand why we're exiting. So now, frick's sake. So now the pretty thing here is I don't have to repeat the print in the switch case for the different operations. I just remember which function is it going to be, and then I just call that selected function for those 2 values we have. Let's see if I made any mistakes or if it compiles. Undeclared O, because we never said we were going to have a character that's an O. What else am I doing? Format specifies type of int for X and Y, but it has float. Well, oh, because I'm not printing the O. I should be printing the O. Okay. So now let's look at it. It complains when I don't have enough stuff. And if I do give it values, it actually knows what it's supposed to do with them. So this is very, very, very nice. But as you noticed, I ended up looking in my own code to remember. This is the difficult part for me to remember, that I need to put the parentheses around the name of the thing, and then that the parameters come after. That basically you need to copy this format, that it needs to return a float. It's going to be a pointer to the function, and then it's the types of the parameters. And then to assign a function to it, it's just ampersand, name of the function, ampersand, name of the function. And then when you want to call it, it's just the name of the pointer. So let's add this too. Everybody's still green, so either you guys passed out or everybody understands me fine. So that is now in the repository. Let's take a look at the mini homework that we have for today, and then take a look at the big homework so that we are not horribly confused. I'm also going to link you guys, just in case, the codes we just worked on. You can also look at the codes I did last semester. I like writing a new code instead of just talking about the previous one, even when they end up being very similar, because it's a bit overwhelming when there's a lot of code to start with. But when I write it little by little, I kind of hope that you guys catch on a little better. So these first 3 we just did today, and the matrix one we did today. The others, I did them, well, 6 months ago, because it was last semester, doing pretty much the same things. So you can look at those if you need more examples. What we have in terms of the mini homeworks for chapter 5, we have this tiny little thing here. So I have a function f here. What it's going to do, it's going to be multiplying a number by 2. This is a bit shift, that's what it does. And this is a function g. It's actually also going to be multiplying a number by 2, but that's taking a pointer. So notice that the f, it doesn't take a pointer, it just modifies the local copy. And the g takes a pointer, so g actually modifies the copy. So here it says a is going to be 5. So my a is going to be 5, and my b is going to be f of 5. So it's going to be a 10. Then I am going to call g with the address of a. So that 5 is going to turn into a 10. So then I am going to print whether a and b are equal. So it's going to print a 1, isn't it? Because they are equal. They are both going to be 10. I haven't logged in, so I can't grade. Let's log in and then go look at it. If it's still a 5, it might be some other value, and carefully look at the code. So now it's a 3, but it's still going to do the same thing because the B is going to take the double of the 3, and then the G is going to double the A itself. So it should still print a 1. Aren't I clever? Second one. I have a string here, which is a pointer to a character, hello world. Then I have this here is going to be an uppercase L. Then I am going to say that I actually have a pointer S that points to the same T. While that S hasn't reached the end of the string, it's going to keep moving forward. And if it reaches the letter that I had, then it is going to move one more position, and then it's going to break. And then it's going to print whatever S is pointing to at that point. So meaning that when I get to that letter, I'm going to stop processing. But I don't have an uppercase L here anywhere, and there's no to lower here. So by the time S is done, S has actually reached the end of the string. So with my selection, uppercase L, it should just print empty brackets. It shouldn't print anything else. But if you had, let's say, an O, it would skip these, then it would find the O, it would increment one more time, so it would end up printing comma space world. So you need to fixate on what's the value, what this character is going to take to know what answer you need to put in the homework. In the third one, I have two subroutines. One takes a pointer to an integer, and it takes an L. And what it's doing is it's accessing a position L divided by 2. Remember that when you divide integers in C by other integers, it rounds down. So if L were a 5, I would get a 5 divided by 2 is a 2. Not a 2.5, a 2, because it's integer arithmetic. So what this is doing is this is accessing a position in an array that's the middle position. So if I have a 5, it's going to access a position 2. And if I have a 5, the positions are 0, 1, 2, 3, 4. So it's accessing the middle element of an array. What does even do? It's a very similar thing, but it's accessing both L divided by 2 and L divided by 2 plus 1, and it's summing them together and dividing. So it's taking an average of two neighboring cells in a sequence. So what does this mean? If I have an array of length 5, like I just mentioned, let's say 12, 4, 3, 9, and a 5, and I would call odd, what odd would return me is the value in the center, that's a 3. And if I had an array that's a little longer, if I had a 12, 4, 3, 9, 5, and a 4, and I called even, I would get the 6 divided by 2, which is a 3, 1, 2, 0, 1, 2, 3. So I would be getting 9. I would have it summed with the previous one, which is a 3, and that would be divided by 2. So it would end up giving me a 6. Okay, now my array here, it's initialized by writing here. It's just a regular array, not like a fancy pointer thingy. And it's important to remember to put this number in here. These numbers, know that they're ordered from the smaller to the larger, and your x is always going to be larger than 12 and smaller than 84, so the order is not going to be messed up. This is simply how long the array is, and we have a function pointer. We have a function pointer here for what are we going to use. And it's going to check if the length is even, we're going to use the function even. If the length is odd, we're going to use the function odd. Then we're going to call the function that we were using to print out. So let's look at this array here. 1, 2, 3, 4, 5, 6, 7, 8. Like it says here, it's length 8. So 8 modulo 2 is going to be a 0. It's an even number. We're going to use the routine even. So what's it going to do? It's going to take these two middle elements. It's going to sum them together, divide by 2 integer division, and then print that out. So I have a 12, and that's summed with a 74. So I get an, what, 86. That 86 divided by 2 is going to give me a 43. So this code should print out a 43, and I just did something horribly wrong. These three, it should be the 12 and the x. What on earth am I messing up here? X is 74. I don't even know what I did wrong. Let's run the code. Maybe I'm just too sleepy. Let's actually put it in a repository so you don't have to copy paste it if you want to run it too. Documents, GitHub, C. Let's go to chapter 5. Let's make an exercise 5.3.c. Take the stuff here, put it here, put a 74 here, compile, and run. 0, 1. Oh, it's because it's a +1. I'm using a +1 instead of a -1. When I explained it to you guys, I was going to the previous one and not the next one. I was assuming that I was using a code that would get the median, but this is actually not the code that gets the median. I made a trap for myself. So I am not summing the 12 with the 74. I am summing the 74 with the 84. So I'm actually getting a, what, 158. And that's going to be a 79, half of it, and that's what it's printing. I fall to my own traps all the time. All the time. Okay, let's push this in. So it should be really easy and really quick for you guys to get the 3 points for these exercises, because by what I just explained, everybody's going to have a 1 in the first question. Everybody. And in the second one, just look where, if anywhere, does your character appear, and you know what's going to be remaining. And in this one, you're really just going to sum together these two numbers and divide by 2, because it's always going to be even. So we're always going to take the middle and the next one. And the middle one's always going to be the x, because this is a 4. It's 8 divided by 2. 0, 1, 2, 3, 4. And then the 4 plus 1, 5. So these two are always the ones that are going to get summed up. So you don't really have to run these codes to get these points. So just please, to make my day, please, please, please respond to these 3 questions as soon as you can here. I think you guys already did. I see a 3 and a 3 and a 3. So that's pretty good. And I was dumb enough to close the thing. We are going to read the homework. And if it scares you guys too much, we can also modify the homework. But this shouldn't be extremely hard, and this should be extremely entertaining. At least last year, no, last spring, last semester, people were extra happy doing this. So I would kind of hope you guys also be extra happy doing this. We are going to implement a Minesweeper game. I don't know if you guys have played Minesweeper, so I'm gonna first explain this, then I'm gonna show you Minesweeper, some place where you can play it online. Can we please, I'm gonna reset the votes and vote green if you have actually played Minesweeper. Vote yellow if you have played but you don't actually know how to play it. So I'll know how much to explain about Minesweeper. Put the gray one if you never ever played Minesweeper, if you have no idea how to do this. Okay, one person kind of knows it, but doesn't know how it works. One person actually knows how it works. Waiting for other two people. And then I think I'm just going to go to the whiteboard to explain this, since two people don't actually know how it works. So this is essentially going to be a two-dimensional array. You can use the code I already gave you for the little matrix as a basis. And I'll show you on the whiteboard how this works. So in Minesweeper, we have a regular array, a regular grid. Let's say like a 5 times 5. So I would have 5 rows, and then I would have 5 columns. What I do here is that there are going to be mines. The mines are going to be placed here, and the person playing can't see them. So I'm going to place a few mines. Okay, so those are mines and those are hidden. The player can't see anything when they start. They start blind. When they start revealing the cells, if you click on a mine, you lose. If you click on something that isn't a mine, it's going to reveal the contents of the cell. And what are these cells filled with? They're filled with numbers of how many neighboring cells contain a mine. So for this cell here in this top corner, this cell has 3 neighbors, these 3 here. One of them contains a mine, so there's going to be a 1. This cell, it has these 5 neighbors. One of them contains a mine, so there's going to be a 1. This cell has these 5 neighbors. One's a mine, there's going to be a 1. This cell has these 3 neighbors, there's going to be a 1. This cell has these 8 neighbors. One of them is a mine. This cell has these 8 neighbors. 2 of them are mines. Let's use a different color for 2. Let's use the black for 2. This cell has all these neighbors here. 2 of them are mines. This cell, these neighbors here, 2 of them are mines. This cell, it would have these neighbors. It's going to have a 1. This one's going to have a 2. This one and this one. This one's going to have those 2. This cell's going to have those 2. This cell here is only going to have 1 neighbor with a mine. So does this, so does this. So does this. This one has 2 neighbors that are mines. This one has 2 neighbors that are mines, and so does this. And this one here has 1 neighbor that has a mine. So while you are playing, you will have to logically reason, because you're looking at these numbers, where would the mines be? So it's an easy game to generate. You will just create the grid and you will randomly place k mines. So usually you have something like an n by n grid. You put k mines there pseudo-randomly. Pseudo-randomness is actually pretty easy. In the repository, there's an example for it. If you're unfamiliar with it, also ask on Discord if you need my help on it, on how to randomly choose a row and a column. It's a really easy and fun thing to learn on your own as well. So you'd simply create the array, and then you will place mines. I would use integers for the arrays, and I would put -1s to mark the mines. Then you need to do a double 4, actually a triple 4, because for every cell, you need to consider its neighborhood. So basically for that cell, you need to be looking at the positions that are, if this is row I, column J, you need to be looking at one row smaller, one column smaller, or one row smaller, same column, or one row smaller, next column, or same row, previous column, or same row, next column, or next row, previous column, next row, same column, or next row, next column. So basically it's a little for where we have like a difference of I, like a di, that goes from -1 to 1, di plus plus. And then we need a dj, going to be a quadruple 4, that goes from -1 to 1. And we need to run over these positions. So basically the neighbor position I is going to be the current position I, summing to it the di, and the neighbor position j is going to be the j, summing it to the dj. And then you need to make sure that you don't go off the grid because you will get segmentation faults. If you try to read these cells that don't exist, you get segmentation faults. So you need to add some ifs. If the ni ends up being smaller than 0 or larger than n, you're not going to want to do it. Even equal to n is going to be a segmentation fault. I'm trying to find my phone to take a picture of this. And the same way with the j, if the nj ends up being smaller than 0 or equal to larger than n, then the neighbor doesn't exist and you cannot actually access the value. Taking a picture. But that's, all of this is reasonably easy. Picture of the neighborhood stuff. Of course, I erased the picture. Using that, and then a picture of the little grid I did here, sending them both. So let's play Minesweeper a tiny bit so we get a hang on the logic. So first you set the mines and then you just use this kind of a thing. Quadruple 4, you go every row, like every I, every column, every J, every DI and every DJ to visit all the neighbors. You count how many mines are in the neighborhood. You put the number. If there are no mines, remember to put a 0. And then when we draw this in the game, like in the screenshot that Jair just shared us, in here, the zeros are the blanks. So like this guy has 5 numbers with a mine, this guy doesn't have any. So let's find a playable Minesweeper. It would be cool if I knew how to type. I'm trying to find one that doesn't look like malware. Let's hope this isn't malware. Okay, so let's play this one. I'll show you guys and then you guys play. And it's a good idea to play for a good while before you start programming so that you know what you're doing. So there's 99 mines to find. Of course, you guys are not going to make a pretty window. You're just going to print to the usual output. You can put like hashtags for mines, 1s, 2s, 3s, 0s, etc. for the cells. So don't try to make a window. We're worried about the logic. So the player starts by selecting a random position. It says that 2 of these neighbors are mines. So that's bad luck there. I'm going to click another one. I clicked on the 0. Now, if you want the 5 points, I would like you to try to implement this feature that when you click on a 0, it shows you the entire continuous area of all of the neighboring cells that were also 0. But you can get 4 points if this doesn't happen, if the person has to click on the blank ones one by one. Oh, I forgot to change the view. you can still get a you can still get 4 out of the 5 points. So, okay, so now I have managed to reveal a tiny little bit. So now what the user is going to do is mark that this is going to be a mine. So what's your user actually going to be doing? They're not going to be clicking. They're going to be writing to you, kind of like when you're playing, what's it called, Battleship. They would tell you, I would like to click on row 7, column 20. I would like to click on row 3, column 5. And then when they type what you want to reveal, then you are going to reveal that particular one. When you click on a mine, you lose, and then it would show you all the mines. You can also make it so it shows everything. So basically you need one array that remembers the positions and another array possibly, or some weird hack on the same array that remembers which positions have been revealed. So let's try to play a little better now. I'm gonna try to get a random opening first. So there's a mine there, definitely. There isn't one there. Then now what I did is I double clicked on the one that already had all the mines around it marked. You don't have to do this functionality either. It's just a quality of life thing. So your user should be able to keep playing. There we go. There we go. Here too. It's kind of easy looking at the numbers to reason until you mess up. Like I marked a mine here, but there isn't one because it already had the 2, and that's why I died. Going again. Come on. Probably the only person in the world streaming Minesweeper on Twitch. One mine, second mine, that one opens. That has to be a mine. That has to be a mine. These two have to be a mine. This has to be a mine. These both have to be a mine. This can't be a mine. No mine here. No mine here. Has to be one here. Okay, what else? One of these has to be a mine. Both of them can't be, so this can't be. One of these two has to be a mine, so none of these 3 can be. One of these 2 has to be a mine, but that doesn't help me. Here, 2 of these have to be mines, but I don't know which ones. It could be this one and this one. 2 of these have to be, and they can't be both these, so there has to be a mine there. So now this guy only has 1 mine here. So for this guy to have 3, there has to be 1 here. I might have made a mistake there. Okay, I'm fine. So now this one and this one have to be. This one has to be. This can't be, can't be. All of these 3 have to be. This can't be, this can't be, this can't be. This has to be, these can't be, has to be, can't be, can't be, has to 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 be, can't be. You guys can start playing yourself too. I put it on Discord where the game is. Has to be, can't be. Oh, that was just a misclick. I was going to mark it and I blew it. I'm probably going to sit here until 8 p.m. trying to get this thing to get cleared. When you have understood how to play the game, you can change your vote to green. It would be very helpful if everybody could try this. It's almost always a bad idea to try to write a program to do something that you don't actually know how to do it. So like the first part of the homework is learn to play Minesweeper. Second part of the homework is write a Minesweeper game. One of these has to be, so this can't be. So this has to be. This has to be, and this has to be, and this has to be, so this can't be. This and this have to be. One of these has to be, this can't be, has to be. One of these has to be, these can't be, this has to be, this has to be. Has to be, has to be. Doing decent, one of these has to be, but they can't both be. So this has to be, it's kind of risky already. This has to be and this has to be, so that can't be, so that can't be, so this has to be, that can't be, those can't be. This has to be, those can't be, this has to be, this has to be, can't be, has to be. This has to be, this has to be as well. This, one of these has to be, so that can't be. One of these has to be, so that can't be. Two of these have to be, but they can't be both those, so it has to be this one. So this has to be here, this has to be here. I think I'm gonna have to do another lucky shot too soon. This one, these two can't both be, so this one has to be. This one has to be. This one has to be because of the 4. So a lot of people think this is a game of luck, but there is a luck a couple of times you need to get the initial opening. The rest of it is you just calculating in your head, doing like pattern recognition of what goes where. These two have to be. This one has to be. Have to be. Has to be. Have to be. Have to be. Can't be. Has to be. Can't be. Have to be. Can't be. Can't be. I love the 5s because you can put so many flags at once. Have to be. Have to be. This one has to be. This one has to be. This one has to be. They can't be. This one has to be. This one has to be. That can't be. This has to be. This has to be. This also has to be. Out of these 5, these 2 have to be. And I won. Whee! And you don't have to put a timer. If you want to, you can figure out how to get time in C. It's not really complicated. So I'm gonna write a couple of things like as a remember to do for the homework list. Learn to play Minesweeper. Learn to generate random integers between 0 and n-1. You're going to have an n by n Minesweeper. You can make it just a rectangular. You don't have to make it like a square instead of just a rectangle like here. You can make it the same height and the same width. You're going to position the k mines at random. And then you're going to ask the user for row and column. You're going to put some kind of a while there. If the user reveals a mine, they lose. If it's not a mine, then you reveal, meaning that you redraw the whole field, revealing some of the slots. So you need actually to have 2 things in memory. one of the minds and the numbers in the one 2D array, and then in another 2D array. Or a wild hack, you can actually do it with just one, but life is a little bit uneasier that way. You need to remember which cells have already been opened. You can optionally do stuff like mark minds. You could optionally add a reveal of zones for blanks, like when there's 0 minds, you could do the continuous reveal, but that's really optional. I'd be very happy if you just do a regular one. You could optionally have a timer, and then you could have optionally the double click thing. Like if the user selects a position that's already been revealed, that means that they think that all the minds have marked there, so you auto open all the neighbors. That's also optional. When all the K-minds are marked and all the squares that are unmarked are revealed, all unmarked, the user wins. And then you would congratulate, exit the game, or ask them if they want to play again, something like that. And our reference card is very helpful for the stuff that we might optionally want to include. Let's find the stuff that I was interested in. I can't find anything in this card today. Here, pseudo-random integer. Here's the part for the random numbers. So it's stdlib. So you can just figure out how it works. There's also a file in the repository that uses this, so you can check it there as well. And the two-dimensional array stuff is very much like in the matrix that we were looking at today in the example code. So this is what I would like us to do, and I will make a little poll. Put green if you think you're good to start working on this homework. Put the question if you have a specific question you would like me to answer at this time. Put the confused thing if you think that you're going to figure it out by watching the video and you don't actually have a question now, but you're not entirely sure what to do yet. Okay, one person is going to figure it out. One person knows what they're going to do. 2 other people probably panicked and passed out. Another person has swiped. Okay, I think we're good. So I'm going to stop the stream. The part about auto exporting to YouTube seems broken at the time, but I'm going to download the class and I'm going to manually upload it to YouTube so you can look at it even after it wipes away from Twitch. Remember to ask on the channel if you have any questions. It would also be really nice if you could paste like screenshots of what you've been doing. I really recommend subroutines. It's very helpful to make one subroutine for printing the view, another one for asking for the row and the column, another one for placing the minds, one for making the numbers, etc. So you can make it modular. It isn't very bad. This is not a very difficult thing to do. Please refrain from Googling code. You don't learn anything when you're trying to stupidly copy somebody else's Minesweeper. It's better to have a really tiny non-functional Minesweeper that you did by yourself than this glorious thing that works wonders, but you have no idea how it works. Any help you need, just let me know, and we will admire your Minesweepers next Thursday.